All right, in this video we're discussing more about displaying data. In our last video we talked about the difference between a categorical variable and a quantitative variable and spent the entire last video talking about how you display categorical data. Well, in this video we're talking about how to display quantitative data, dot plots, histograms, stem and leaf plots. In our next video, we'll talk about one more way to display quantitative data using box plots, but we'll need a few more tools before we talk about that one. By the end of this video, I hope that you're able to answer questions about data when you're given a dot plot, histogram, or stem and leaf plot, and you're also able to construct a dot plot, histogram, or stem and leaf plot. Okay, so here's an example of a dot plot. It's a data set I just found online. And you'll notice that there is no y-axis. There's no y-axis over here, which you may kind of by default think there should be. And all we do is we write down the numbers here, and usually it's rounded to the units place. But if the data set is small, like we'll see in a second, you may go to the tenths or the hundredths, depending on how specific it is. But you usually need to round off your data so that you have you can kind of so that multiple data points can line up on the same space. Okay, and as you get the same number more than once, you just kind of stack the dots, like you'll see here. Okay, this is called a dot plot. Okay, so let's make a dot plot. I pulled GPAs of seniors at towards the end of the year, and this is kind of what it was. So what we'll do is we will put a dot above each point and kind of just stack the dots. So the first one is 1.5 and 1.7, 2.1. Now I happen to order these to be nice, but 1, 2, 3, 4. There's 4 2.1s. 1, 2, 3, 4. 1, 2.6. 0, 1, 2, 3, 4, 5, 6. 2.7s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 2.9s. 1, 2, 3, 4, 5, 6, 7. Anyway, you get the idea. You just stack the dots and you'll create kind of a graph of what a display of what the graph looks like, and we can then talk about the distribution and where the mean is and where the median is. Things we'll talk about more next video and the very beginning of this next year. Okay, here is, I think it's the same data set as before, except now it's displayed as a histogram. Okay, now I know it looks like a bar chart or a bar graph, but the difference is now it's quantitative data instead of categorical data, which means on this side we still have the frequency like before. Here we have our quantitative variable. Very important is that the bars are now touching, which is a really big difference between this and a bar chart, is that the bars are touching, which makes sense because there's a specific order, and the different bars or the bars touch each other because their intervals touch each other. That kind of makes sense. Now, a couple of things to talk about is that these are called bins. Okay. Okay. So we talk about the bin width, or the width of the interval that the numbers can fall into. Okay, and we are able to choose our bin. Now, our bin width. Now, all bins should be the same width. So they all should be, in this case, I think it's about 4. It's a bin width of 4, but we are able to choose what that is. Now, obviously, we're going to pick, something less than the least and more than the biggest one, but we want to have it so that it's not too big or not too small. It's kind of a gut instinct decision of what the bin width should be. Okay, so here's our data of the same data we had before of student GPAs. Okay, now our data goes from 1.5 to 4.4. Okay, and based on the data, we probably want to have somewhere, we could go um, 1.5 to 2.0, and then 2.1 to 2.5, and 2.6 to 2.9, no, to 3.0, and then 3.1 to 3.4, no, 3.5, 3.6 to 4.0, and 4.1 to 4.4. Okay, now a couple things to keep in mind is that the bins have to be the same width. So here they're about 0.5 if you include the endpoints. Um, Also, the bins do not overlap. So you can't go from 1.5 to 2.0 and then 2.0 to 2.5 because where do you put 2.0? Do you put it in both? Do you put it in one? To kind of erase that confusion, we just make sure that they don't overlap on what the bins are. Okay? And then you simply go and you kind of make a scale over here. I have no idea how big it's going to be since I haven't really counted up what it'll be. I think the biggest one probably will be around this bin. And so I would count it's from here to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 26, 27, 28, 29, 30, 32, 33. Okay, there are actually 34 numbers in that in this bin. And so make sure my scale goes up to, 35 or so. And I probably would round off by fives. That's going to be big enough. 1, 2, 3, 4, 5, 6. Okay, and you get the idea. We will count. Actually, let's do a couple between. In this category, I already counted. There's 34. And if it's kind of hard to see, sometimes you'll see written above here um, the number. It's not widely done, but sometimes it is. The number that would fit into that category, just so it's super clear. Okay, between 1.5 and 2.0, we only have 2. Between 2.1 and 2.5, 1, 2, 3, 4. Between 2.6 and 3.0, quite a bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 22. Okay, and you get the idea. We can keep going, but the bars are touching, the same width, and what we choose the bin width to be could be some other things. We could pick a bin width of zero point 0.3 instead, or 0.2. It doesn't want to be too narrow and doesn't want to be too spread out, but you want to be able to represent well the distribution. Okay, stem and leaf displays. You've probably seen this before, a stem and leaf plot. The same data I think we had before. Maybe it's a new data set, I can't remember. But what you have here are what are called the stems. Okay, and over here are called the leaves. Okay, now one important thing to point out that students sometimes have a problem with is the fact that the leaves must be in order. Okay, unlike the dot plot where you can just kind of take numbers in whatever order it's given to you and just kind of plot the points, you can't just put the leaves over here in any order. It has to be in numerical order. Okay, now I don't think there's a set way whether or not the lowest number goes here or goes here. The numbers obviously have to be in order, but I've seen it both ways. I don't know if there's a standard way of doing stem and leaf plots if the zero's on the bottom or on the top. But as long as it's in order, and then these numbers go in order, and with these numbers, it's always low to high. Okay, it's often very, very nice to have a legend to see whether we're talking about units or tenths or thousands, that we can know exactly what it means. Okay, the leaves are almost always the units place or the last place. I shouldn't say units place. the one digit. Okay, it's almost always one digit. Occasionally you'll see one where there's two digits, if the data is really spread out or something. Usually there's only one digit per number in the leaves. Okay, so the same data set, again, there's only one bar, which will separate our stem from our leaves. Now in this case, if I did just units with 1, 2, 3, 4, our 3 would be pretty long. We go from 0 all the way, so it'd be all of this data would be, 70 or 80% of our data will be in that one stem. So because the data is so close together, we can create, I can't remember the name of it off the top of my head. I should have looked it up. But there's a way of breaking up between highs and lows. I'll start at the bottom and I'll have one low, one high, two low, two high, three low, three high, and four low. Actually, I won't need a one low. And what I mean is that they'll go from 0 to 4 and then 5 to 9. Okay, so the one high will start off with 5, 7. Okay, and then my 2 will go. Let's see here. There's 1, 2, 3, 4 ones, and then I'll do 6 would then be in the high because it's 5 to 9. So 6, 1, 2, 3, 4, 5, 6, 7s. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7 nines. 1, 2, 3, 4, 5, 6, 7 nines. Okay. Whoops. It should be a little bit lower. Okay, and we can keep going. Think you get the idea. The reason we break it up into high and low is because it gives a better distribution of what the graph will look like. Okay. All right. If you take a minute and summarize the data we've talked about, histograms and dot plots and stem and leaf plots, things you probably have seen before back in Algebra 1, but it probably has been a couple of years. It's not really too difficult, but we'll be using and displaying these types of graphs and displays throughout the year, especially the very, very beginning of the year. Something you need to be aware of. Okay, so take a second, summarize the things in this video, and try the practice problems.